Good morning, students. Today we are going to discuss about zero work. In the last two classes, we studied how we can measure work by using different units. Now we are going to see zero work. We discussed that when both force and displacement are in same direction, what is the formula for work? Even we studied when force and displacement are opposite to each other, what is the formula for work? Now, in today's class, we are going to talk about zero work. Let us see what is zero work. When work done is said to be zero. We will try to see some examples of zero work. Okay, here one man is pushing a wall, right? So this person standing in front of the wall and trying to push it. When he is trying to push it, but he is not able to do that. He is unable to move that wall. That is what we are observing. What is the displacement of the wall? Displacement of the wall is zero. He has applied force, no doubt, but the displacement is zero. That's why we can say that work done by his force on the wall is zero. Why? Because there is no displacement even though force is applied on the wall, right? So we can say that no work is done by him. Now we'll take one more example. Here you are able to see one coolie is holding luggage on his head and he is standing, right? So coolie is standing with heavy load on his head. And now what is the work done by him? Here also the displacement is zero. Just he is standing. That's why we say a displacement is zero. So displacement is zero. Therefore work done by him is also zero. No doubt he kept that luggage heavy load on his head, but he is standing. That's why the work done by him is zero. We will see some more examples of zero work. So what are some more examples? When we talk about the motion of earth around the sun, so carefully observe motion of the sun. We know our earth and all planets, they revolve around the sun, right? When they are revolving around the sun, if you observe, so earth is in motion and it is having displacement, and we know that it is moving in a path without centripetal force or without a gravitational force of attraction. Earth never moves around the sun, right? That means there is a force, and that force is acting towards the center of the sun. Why? Because sun is attracting planet Earth. Sun is attracting. That's why the force is always towards the center of the sun. Now what about the displacement? If you take a tangent to the path in which Earth is traveling, you can see the displacement gives the tangent drawn to that path. So here the tangent itself is representing the direction of displacement. When you observe carefully a displacement and force, how they are in this. So displacement and force, they are making 90 degrees angle with each other. When they are making 90 degrees angle with each other, then we know we already studied the formula for work in the previous class, that is W is equal to Fs cos theta. Here angle is 90 degrees. That's why when I substitute the value of 90 degrees as an angle, I can write W is equal to Fs cos 90 degrees. We know cos 90 degrees is 0. Therefore, W will become 0 automatically. That means here displacement is there. We know that Earth is moving around the sun. Displacement is there and force is also there. But even then, the work done is 0. Why? Because force and displacement are perpendicular to each other. When they are making 90 degrees angle with each other, the work done will become 0. So this is the point you people need to keep in our mind. What is that? Work done by the sun, so to move the earth around it is 0. Okay, now we'll see some other examples. We can take us also. Work done in carrying a load on head. We will see this example. Here you are observing one person or one man is keeping load on his head, right? Is keeping load on his head and is carrying that load along with him, let us assume. So when person is taking the load and moving, we know that definitely the direction of force in this. Why? So we know that he is carrying the load in horizontal direction. That means the displacement is along the horizontal. What about the force acting? The force acting, the gravitational force of that load is acting vertically downward. That means the force is acting downward by making 90 degrees angle to the displacement. So here also angle is 90 degrees. So when we substitute angle 90 degrees in cos, we know that cos 90 degrees 0. Therefore, work done will become 0. W is equal to F into S into 0. Therefore, W is equal to 0. That means the work done by the potter in carrying the load by moving horizontal is 0. He is keeping the luggage on his head. He is walking horizontal. Then definitely we say the work done by him is 0. So this is what we have taken some examples for 0 work. Now what is the conclusion by all these examples? What conclusion we can draw on? What conclusion we can get? So from all these examples, one thing is sure that work is said to be 0 if force and displacement are perpendicular to each other. First point. The second point is force alone acts and there is no displacement. Okay, what are they? So number one, force is acting but displacement is not there. Then also the work done is 0. Both force and displacement are there but they are perpendicular to each other. So in that case work done is 0. So these are the conclusions we can get from this. Now we learned so much about work. Now we'll try to solve some problems by the concept what we learned till now. With that we'll try to solve some problems. Let me give the first problem in this. So what is the first problem? In this worksheet I'm taking the first problem is this one. What is the first problem? So whenever a problem is given, you must read the problem very carefully. After reading the problem, try to understand the problem. Then you apply the concept which you learned. Then only you will get answer. Some students, they will try to do problems. Don't do that mistake. First read it, try to understand. After that, do the problem. Now we'll come to this problem. In the problem, they are asking a question like this. What is the question? How much work is done by a force of 10 power 6 dynes in moving an object through a distance of 1 meter in the direction of force? Now when you observe carefully, they are saying the force is applied, that is 10 power 6 dynes. And because of this force, that object got displacement. That displacement is in the direction of force. How much displacement? 1 meter displacement it got in the direction of force. Now we will try to use our formulas what we learned, right? So first we'll write the data. Data is force cap power 6 dynes. But I want to take everything in SI system. Why? Because they have given distance in meters. But whereas force they have given in CGS system. That's why I'm converting the given force into SI system. We know that so 10 power 5 dynes is 1 Newton. That's why I'm directly writing so 10 power 6 dyne as 10 Newton, right? Now the displacement is 1 meter and we are able to see force and displacement are in same direction. What is the formula we learned? The formula is W is equal to F into S. Therefore, I am just substituting. So force is 10 Newton and displacement is 1 meter. Therefore, the work done is 10 joules. So very easy question, right? So this is how we can do problems. Now we'll see one more problem. So let us see the next problem. Here I will read this problem first. What is that? A body at rest has mass 10 kg. It is moved by a horizontal force of 5 Newton on a horizontal surface. Calculate the work done by the force in 8 seconds. Now, so from this problem, we will try to collect the data. They are saying body is initially at rest. That means initial velocity is 0. Mass of the body they have given, that is 10 kg. Now, on that body they applied force. How much force? 5 Newton force. And they are asking calculate the work done by that force in 8 seconds. When you observe problem very carefully, in the problem they have not given displacement. How much distance it traveled, that they have not given. Then how we can calculate work? When distance is not there, we can get distance. How will get distance? By using the other data. What are the other data is available? When you observe carefully, they have given time of travel. They said in the problem, in 8 seconds, how much work is done. That means it is having displacement for 8 seconds. So we can calculate the displacement in 8 seconds. Right? Here we know the formula for work. W is equal to Fs. But S is required. So to solve this problem, to find out S, we are using one more formula which we already learned in force and laws of motion chapter, that is Newton's second law, F is equal to ma. Right? When force is applied on the body, definitely body gets acceleration. We have to calculate that acceleration, and we even know equations of motion. By using these all, we will solve this problem. Let us see how we'll solve this problem. They have given bodies at rest, therefore I am taking initial velocity u is 0. Mass of the body they have given 10 kg, right? And force applied on it is 5 Newton. And we know the time, how much time it traveled, that they have given 8 seconds. Now they are asking calculate work. For this, we know this formula W is equal to Fs, but S is still not there, right? We need to get S. For that, we are using equation of motion, which we already learned in the previous chapters, force and laws of motion. Equation, displacement S is equal to half a t square, where S is the displacement, a is the acceleration of the body due to force, t is time of travel. So in this, a is required, right? You want to get S by using second equation. Time is there, but a is missing. How will get a? We know Newton's second law, F is equal to ma. From that, a is equal to F by m. We already got F and m, right? They have given in the problem. So I'm substituting F value and m value. When we substitute F value and m value, automatically you will get acceleration. So I substituted all those things. Equation 1, equation 2, equation 3. So now in the place of F is F only, but in the place of S, half a t square we have to write, but here a is F by m, therefore half F by m into t square. Now I'm substituting the known values. Force, right? So we can take a force value as what? They have given 5, right? And mass is 10 kg, half into, so again 5 by 10, right? Into, the next what happened? So time square means t, that is 8 into 8, 8 8s are 64. So when we solve this, we got answer 32 joules. This is how we can do problems. Now we'll go for another problem. So what is another problem? So this problem, read carefully. What they are saying, if a servant lifts 10 meter cubed of liquid from a tank which is at a depth of 40 meter. If the work done by him is 1600 joules, then find the density of the liquid. So this is a hybrid question. Why? Here so many concepts we need to apply. Then only we can get answer. Just by using work formula, you will not arrive the answer, right? So then how we will do this? Let us see carefully. Here they have given the volume of the liquid. What is that volume of the liquid? 10 meter cubed volume of liquid is lifted. From where? From the tank. Who is lifting? Servant is lifting. From what depth is lifting? From 40 meter depth. That means, so that water got displacement, or I say that liquid got displacement, and that liquid displacement is 40 meter. Okay, and in displacing the liquid, he did some work. That work is 1600 joules. Now we have to calculate the density of that liquid. Here to support, they have given even G value. G value is 10 meter per second square. Now let us see what we can get, right? I'm using the given first. Volume is 10 meter cubed, depth is 40 meter, and work done is 1600 joules. Density of the liquid we need to calculate. G value is provided. Now, so we know displacement. Here force is nothing but the weight of that liquid. Weight of the liquid we learned already in previous chapters. Weight of the liquid is mg. That means the force is mg here. In the place of force we are writing mg. Now displacement is nothing but the depth. Therefore displacement I am writing it as h. Right? So W is equal to mgh. Now so these values I am substituting here. But mass of the liquid is not given. Then how will get mass of the liquid? We know that. So mass is the product of volume and density. So I am writing volume into density as a mass. Then the formula will become work done is equal to volume into density into acceleration due to gravity into h. Now all the data is with us. So when we are substituting this data, we are getting density. What is the density? 0.4 kg per meter cube. This is how we can calculate density of the given liquid. So this is a hybrid question. Here number of things we mixed, and because of that we got this answer. So we'll stop here. We will see in the next class. Thank you.